In this section, we're going to learn about non-linear simultaneous equation and then how is it related to discriminant. So if you still recall, there are some conditions on the discriminant and it is related to the nature of roots. So we're going to add in one more layer. So in this section, right, the simultaneous equations that you're going to learn is not the linear simultaneous equation. So in Sec 2, you learn about linear simultaneous equation, which you will usually do it by elimination or substitution method. But right now, okay, you will be faced with a linear equation and a non-linear equation. So the effect of doing a linear with a non-linear, okay, we'll see in a while. So you will get more than one solution. So previously in your linear equation, when either you do elimination or substitution, you only can get one answer. But right now, you are going to see one answer or two answers. Okay, so I illustrate the technique first. So now the focus, right, will be on the technique of non-linear simultaneous equation first. So it will look something like this. So you will still get a normal set of simultaneous equation. So there will still be two equations. And you got to observe that one of them is a linear equation. So which is the one that is linear? So if you observe the power of x and y, if the power for x and y are both power 1. So for power 1, so for x and y, if both are power 1, so this is known as power 1. So that will be a linear equation. So if you observe any algebra with 2 and above, that is considered non-linear. So in this case, right, this is there's the x square here. So the second equation is non-linear. So for power 1, then we can consider it linear. Other than that, right, it will be non-linear. So you're going to observe a variety of power. It's not just x squared. It can be other power, which you will learn more about it. Okay, so recognize which one is a linear equation and which one is a non-linear. So for linear to happen, it has to be power 1. Okay, why do you need to recognize a linear equation? Because usually from the linear equation, you got to make subject. So when you are doing a simultaneous equation, linear with non-linear, there is only one method. You cannot be doing elimination anymore. So there's only one method. You can only do the substitution method. So the elimination method is no longer applicable when you are doing simultaneous with linear and one non-linear. Okay, so detect the linear first. The linear is the one that make a subject. So you got to rearrange the linear to make y the subject. You can choose to make x the subject. It doesn't matter. As long as you choose, you have a subject. Your subject can be y, 1y, or your subject can be 1x. That is a similar idea when you were doing simultaneous in Sec 2 in the simultaneous linear equation. So from the linear equation, I'm going to make a subject. So my subject is y. So I got a brand new equation. That's why we label it as an equation 3. So from here, I'm going to insert this into the second equation. So y is representing 2x minus 4. So I'm going to change out the y. So originally the y has been changed out. So when you successfully substitute y away, you find yourself with a quadratic equation. So you find yourself having a quadratic equation in x. So whatever you learn in your quadratic equation, so what do you learn in your quadratic equation? You shift everything to one side so that you have an equal to 0. You can factorize. So in Sec 2, you learn to factorize, and then you do a first bracket equal to 0, and a second bracket equal to 0. So, but right now, because you are already at upper set, so the solving of a quadratic can also be done by the quadratic formula. So up to you. So for me, I will only factorize if the number look easy. If the number look complicated, I will go back to my quadratic formula. So because of the quadratic formula, you get two solutions. So if you look carefully, now I got two solutions. Compared to what you did it in step 2, you only got one solution. So if I put the solution into the back to the subject, okay, so you're going to put x equal to 1 back into your equation 3. So if you put x equal to 1 back into your equation 3, that will help you to find the corresponding values of y. So this became a pair of answers. So this is one pair. So there is one pair of answers. So if you put x equal to 4 into the subject again, it will get you another y. So that is another pair of solution. So we classify it as a pair. You cannot mix them up. So you cannot mix x equal to 4 and y equal to, so if you write something like this, right, x equal to 4, y equal to minus 2, that's wrong. So I will mark you wrong for this. Because this is not considered a pair. So we got two pairs of answers. So we got two pairs of answer. So what does this two pair of answer signify? So it kind of signify intersection. So these two pairs of answers, so we got two pairs of answers, two pairs of solution. So these two pairs of solution can represent two coordinates of intersection. So what do we mean by two coordinates of intersection? So technically the linear graph, the linear equation is a straight line. So this is the linear equation. And then the curve is and then the non-linear is supposed to be a curve. So maybe the curve will look like this. And then you will see two meeting points. So this one can be a coordinate. So it will be 1 minus 2, it will be 4 minus 4. So I think I'm just putting it here, but it doesn't make sense if I really sketch it out. So this will be the two coordinates that we are talking about. So when there are two pairs of solutions, it is known as two coordinates of intersection. We also consider it two real roots. So this is what we'll consider like two real roots. And then it should be what we call real and distinct roots. Okay, so a linear and a non-linear. So the technical idea will be you make subject from linear and put it into non-linear. So you will encounter quadratic equation, which you can do it by factorization or the quadratic formula. So in this case, there's an alternative method. Okay, not every time you may have an alternative method. So in this case, right, we can directly chunk this one in. We can directly chunk this one in. So in this case, because it's nicely done already, we can chunk this in as a substitution. And then you still come back to the same quadratic equation. So you still got the quadratic equation in X. And you're still getting the same answer. So it will still give you the same answer. So generally, sometimes we can do that. Otherwise, right, as a rule of thumb, we will make a subject from linear and put it into the non-linear. Okay, so this when there are two solutions, two pairs of solution, it also represents two coordinates of intersection. Okay, so I'm going to go on to another example. So here, if you look at this example, the question is asking for the coordinates of intersection. So, and we got a curve. So the curve is supposedly the non-linear. So where is the non-linear? So this part is the non-linear, and this part is the linear. So the linear is always a straight line. So label the equation first. Label it as equation 1, equation 2. Identify the linear and identify the non-linear. So general rule of thumb, from the linear one, you make subject. So in this case, right, it looks easier to make subject based on X. If you want, you can make the subject based on Y, can also. So if you like Y to be the subject, right, you can actually do something like this. And then Y will be your subject. So that is your choice. But if you compare this idea, would you want a fraction as a subject or would you want a non-fraction as a subject? It will be much easier to work with a non-fraction. So after this, your job is to plug the subject into the non-linear. So don't forget, you got to sub. Here you got to sub twice. Okay, so there are two instances in the non-linear that you need to sub X, so substitute inside. So once you substitute inside, you will encounter an expansion that you learn in Sec 2. So in Sec 2, you learn this expansion. So this is the part where some people will miss out. So they will miss out on the Sec 2 expansion and they couldn't do this correctly. So once you miss out on this expansion, you find that you will not get anything correct from there on. Because anything you do from there on is not correct anymore. So you end up losing the 5 marks just for this time. Okay, so that's one thing. So in this non-linear simultaneous, there's a lot of chance that you will be using your Sec 2 expansion. So your Sec 2 expansion got to be all right. Then you do your normal expansion. And eventually now you are also getting a quadratic equation. But this time around, your quadratic equation is in Y. So your quadratic equation is in Y. Method is still your Sec 2 factorization method, or it can be your quadratic formula. So your quadratic formula can also be applied here because it's still a quadratic format, except that it's not a quadratic in X, it's actually a quadratic in Y. So you got two possible answers for X, which of course you need to sub back into your equation. You sub back into your X. So if you sub back into your X, you get a pair of solution. So remember, this is a pair of solution. So the pair will be X equal to Y and Y equal to this. So if I like it to be in a coordinate format, right? So it will be 4, 3/2. If the question asks for coordinates, then you got to put it into a coordinate format. If the question didn't, you can just express it as a pair of solutions. So you can express like this. Okay, so if you sub your Y go to -1, you get another pair. So if the question didn't ask for coordinate, this will be your answer. But then right now it asks for coordinate. So the solution will be -1, -1. So these two solutions represent two intersections. So where does the two intersection come from? It comes from a small graph and a straight line. So the straight line will be the linear graph, the linear equation. The non-linear one is usually the curve. The question will already say that there is a curve. So here, that's the theory. So right now we got two pairs of solution. So we got two pairs of solution, and the two pairs represent two coordinates of intersection. So these two coordinates of the intersection represent two roots. So these two roots are what we classify real and distinct. Okay, so will there be one solution? Yes, it's quite possible. So there will be some situation where a curve and a straight line only ends up as a one solution. So it can look something like this. It can look like this. So there's only one intersection. So this kind of one intersection, one root, if there's only one intersection, right, that is considered only one root. So this is what we'll call the real and equal roots. And in this case, when a straight line cut the curve at one point, we got a special phrasing for it. The phrasing will be the straight line is a tangent. Is a tangent to the curve. So the idea of a tangent is it just brush against the graph. It just brush with the curve. So it looks something like this. So tangent is like brushing against the curve. So the straight line just brush past. Okay, so the straight line just brush past the curve at one point. So that's called a tangent. So subsequently in E-math, there will be one topic that you will learn how to construct a tangent. So at the moment, you recognize that tangent means it just brush past the graph, and then it ends up as one root. So will there be no solution when you're doing all this simultaneous? Yeah, there could be a situation of no solution. If the curve is way too high up for the straight line, if the curve is way too high up for the straight line, or the curve is it's below the straight line. So look at these two scenarios. These two scenarios, when the curve is above the straight line or the curve is below the straight line, so you will end up no intersection. So that means if you have tried to do a simultaneous, you do a simultaneous, but you do not get any intersection. So you do not get any roots. So the discriminant will come in. So in all these situations, the discriminant will come in. So for example, here, so when there are two solutions, which what we'll call the two root solution and real and distinct solution, the discriminant is positive. And if the curve and the straight line are tangent, so in the tangent situation, there's only one root. So the discriminant is equal to 0. And in the situation where you try to do a simultaneous, but then the graph happens to be too high up above the straight line, or the graph is like totally below the straight line, then you end up no roots. So no roots will correspond to a negative discriminant. So this is how simultaneous is being added to the idea of discriminant. But first of all, the technical aspect of simultaneous must be there first. So that is a generic idea first. So the technical aspect is how you execute the simultaneous to get the correct intersection first. And then the concept aspect will be how many roots came out from the simultaneous equation.